Okay. Hey, it's working again. All right. I don't know what the problem is. Let's do this. So, I don't remember Mean Girls. That might shock you. You think so? I do like they were on the math team. Okay. Here we go. This number one question, not super duper important in terms of the AP test. The AP test used to have a lot of pre-calc stuff on it. Okay? They don't have it anymore. But to find an inverse function, gang. All right? And again, I am going to record this. I'll put it online. So if you don't understand something, ask a question. If you want to go back and look, you can. I'm telling you, number one, not crazy important. The way you find an inverse, you ready? If y equals x squared is my function, to find the inverse, you switch the x and the y, because that's what inverses do. They switch x and y. Okay? And then you solve for y. And you solve this for y, you get plus or minus root x. Cool. We usually just think about root x as the inverse, but negative root x is there. But then it's not a function, so it really has two pieces. But that's okay. The point of an inverse is this. If you plug 3 into this, you get 9, right? If you plug 9 into this, you get 3. It's terrible 3. That's what they do. They undo each other. That's it. All right? Again, to find inverses, you just switch the x and y and solve for y. So when you're asked to find the inverse to this question right here, keep in mind f of x is really like the output, the dependent variable. We'll call that the y, really. Okay, you switch them. So you get x equals y over y plus 1. Okay? Then we got to solve that for y, which seems a little tricky, but you know all the stuff you need to do this. It just looks a little unusual, really. You need to get the y plus 1 out of the denominator. We're trying to solve for y right now. We cannot do that when there's a y plus 1 down there. So we cross multiply it up, and we get this. Oops. Can we handle that? You distribute the x into there, you get that. Okay, we're trying to get y by itself. We have multiple y's. We get them all on one side. That gives me this. X equals y minus xy. Cool. We want to get y by itself. We can't combine y and xy, because if there were numbers like y and 3y, we'd put them together, right? But y and xy, we can't do that. So we just factor y out. Wow. So x equals y times 1 minus x, which means that y, if you divide, equals x over 1 minus x, which is somewhere. Is that not an answer?
C.
Oh, there we go. I was going to say, where is it? Does that make sense? Again, not crazy important. You should know what inverses are. But meh, there's like a little rule with slopes later on we'll talk about, but not the end of the world. All right. For 2, semi-important, just in terms of understanding our functions. Gang, I think continuity is a super easy concept. We made complicated. I told you that before. To be discontinuous. All right? The only way a function can be discontinuous for us, really, there's 3 things that could happen, okay? There's some other weird stuff in there, but there's really just 3 big things you're looking out for. We cannot divide by 0. Can we handle that? We do not take the square root of a negative number. And we do not log negative or 0. Those are all undefined ideas. I mean, we got imaginary numbers with the negatives. We don't deal with that in this class, okay? Because x to the 2/3, so this is important. That's the same thing as the cubed root of x squared. Okay? There's no division in there. There's no logs in there. There's a root, but it's an odd root, cubed root, right? That thing's continuous everywhere. Because of that. You all understand what I'm saying to you? You don't have to worry about anything. It might look weird. It doesn't matter. There's no division, no logs, and it's an odd root. Continuous everywhere. E to the x. There's no division, no roots, and no logs. Continuous everywhere. You should know the graph of e to the x looks like this. That's what exponentials look like. Okay? Tangent. You should know what that graph looks like as well. We'll go over that later on, but all you really need to know is that it's sine over cosine. So tangent's a little sneaky because it doesn't look like there's a division, but it is because it's a ratio, sine over cosine. If cosine is ever 0, which it is, at pi over 2 and 3 pi over 2 and 5 pi over 2 and 7 pi over 2, right? That's going to make that undefined. So tangent is not continuous. All right? But 1 and 2 are, so that's the answer to that question. Cool? Excellent. We should know what the graph of e to the x looks like. It looks like this. right? It has a horizontal asymptote at y, so a lot of times you say 0. It's y equals 0, all right? So that is right here, boom. Okay, that again, semi-important for us, you should know that. Basically what that stems from, you guys should know this, e to a big negative number is basically 0. Okay, because that really means 1 over e to the 100, which is really 1 over a huge number, right? And 1 divided by something gigantic is basically 0, okay? That's a very mathematical way to write that out, okay? 4, you ready? This says f of g of x. That means we're plugging g into f. Let's review that real quick, okay? If f of x is x squared, let's make it 2x squared. 2x squared minus 3x plus 1. And g of x is log of x for whatever reason. And I asked you, what is f of g of x? Everybody knows this, right? If I said, hey, what's f of 2? You'd plug 2 in, right? 2 squared minus 3 times 2 plus 1. So f of g of x says plug g of x in where you see x. So that is 2 g of x squared minus 3 g of x plus 1. But g of x is just log, base 10, for whatever reason. So it's that plus that, or minus that plus that. Do we handle that? That's an L, not a 1. 3 log. Make sense? So when they ask you this, although it might look a little scary, they're saying, hey, f of x is this. When you plug g in, you get this. So try that out. If g was a, you would get ln of, it should be x squared, but it's going to be that thing squared, of 1 over the square root of x squared plus 4 squared. We handle that? That would turn into the natural log of 1 over x squared plus 4. That's not what we want. We want ln of x squared plus 4, not 1 over x squared plus 4. Y'all see a difference? Kind of, sort of, maybe? Yeah, right? Okay. And you can see this, if we plugged in this, that's going to become ln of that thing squared. Well, that's not going to do it for us. Clearly, the answer is this. Because if you plug that into there, you get ln of the square root of x squared plus 4 squared. But the square root of x squared plus 4 squared is x squared plus 4, which is what we want it to be. Okay? Possible? Just guessing and checking there, really. That's all. I just plugging it in. Okay? That's also not a crazy important question, but you should understand composition of functions. That's going to matter for us eventually. All right. 5. I'm going to go ahead and give myself a little room to work here. You ready? Let's snag this. No. Come on, you. There we go. Come on over here. Bop, bop, bop. All right. We talked about this earlier. If you have to solve a log equation, you got to get those together. When you're subtracting logs, what's that turn into? Division. Yeah, we all know that. We're geniuses, right? But dividing by 1 over x is the same as multiplying by x over 1. Yeah? And that's just ln of x squared. But that has to equal 2 from up here. So ln of x squared must equal 2. Now, I know you don't like logs, and we went over this already, but still for some reason you block it out in your head. Ln of x squared equals 2 says that. This is base e. E to the second power is x squared. That's what that says. And if e squared equals x squared, then it sure makes sense that e is x. All right. So that's the answer to that question. Wherever it went, right here. Boom, e. Cool. H, again, is composition of functions. Like, they don't ask these questions anymore on the AP test. But they're saying plug g, which is absolute value of x, into f, which is this. So this x squared just becomes absolute value of x squared. That's it. The x becomes absolute value of x. Okie dokie? Now, the reason why you don't see that as an answer is because what's the absolute value of x squared? It's x squared. Yeah, x squared is positive or 0. The absolute value, that's the same thing. That's why it shows this. Yeah. Oh, Mario, what's up? I don't see why not. Good. Okay. Every 7 also not crazy important. But you guys understand what this means? When you plug in 2, you get 3. Yeah? So when you plug in 2, you get 16 plus 4a plus 2b minus 5 is 3. Can we handle that? So we should be able to solve this out, guys. So that is important. Like the plugging in here, whatever. But solving this system of equations we get out of here, you should be able to do. When I plug in -2, I get -37. That's going to give me -8 times 2 is -16 plus 4a again minus 2b minus 5 is -37. So I just plugged in -2 and that's what that turns into. All right? Now, that's an ugly looking thing. We're going to simplify these. This right here is the same thing as 4a plus 2b. That's this part right here. You see that? The 16 and the minus 5 really make an 11. I'm going to move that the other side. Subtract 11 and get -8. So it's kind of stacking them up. I want to get all my constants together. This one is going to become 4a minus 2b. Here we have -16 and -5. That's -21. We're going to add that to the other side. That's going to give me -16. So we have that system right there. All I did was simplify those equations. I have 4a plus 2b equals -8. And I have 4a minus 2b equals -16. And look how nice they are. They cancel them out for me automatically. If you add that up, you get 8a. So that right there, you should understand what just happened there. Are we okay with this? That's elimination, right? But it's already stacked up to do that. Divide by 8 and you get a is -3. And once you know a is -3, my OneNote is again, there we go. You get -12 plus 2b is -8. Add 12 over, you get 2b is 4, which means b had better be 2. Cool. And if a is -3 and b is 2, when you add them together, you get -1, which is C. Okay. Now, 8. 8's a little bit important. So let's discuss this. This bad mamma jamma. Okay. So, you ready? Let's think about this graphically for a second. If I said to you, hey, I'm making up a graph, here it is, it's absolutely amazing. At x equals 4, this y value right here, which is not writing. Y. What do you want? Okay. So, OneNote is not playing nice at the current moment. It's frozen up. No fear. It's okay. How about the weather? You guys ready for fall? Are we excited? Best time of year? What's the best time of year?
Spring.
Spring? Spring's also awesome.
I already got my $5 you go to Costco?
I do go to Costco. They have $5 pumpkin pie?
It's like $5.59, but it's so good.
I don't really like pumpkin pie.
But it's like massive.
$5 is pretty good.
The apple pie is only like $10. But their pumpkin pie is good.
I do enjoy, I don't know, what's your favorite pie? Pumpkin? Pecan pecan maybe?
Pecan's got too much sugar. Winter is the worst.
What is?
Winter.
Winter? No, man, you get yourself a significant other, you cuddle up with them by the fire, things are nice.
I'm just friends though. It's alright.
Sure. Hey kids, check it out for a second. Look, my OneNote's working again. How nice. Look at this graph. If I said, hey, I made this graph, but oh no, I want it to be continuous. What y value should I make it equal at 4? What y value should I make it equal when x is 4? So it's continuous. Yeah, 7. Yes, that would plug it in. That would look like this. Let's say the function I made up just had some name. You ready? You'd write it like this. Hey, it equals whatever it is. I'm just calling it g of x for right now. but everywhere but 4. You all see that? That's taking 1 point out. That's what that does. If I want it to be continuous, then when x is 4, I need this to be 7. That puts the point where I want it to be. Make sense? Okay. They ask these questions like this right here because, you ready? When you put 2 into this, you get root 9 minus root 9 over 2 minus 2. Guess what that is? 0 over 0, right? That means for us, most likely, there's a hole in the graph there. All right? But to find out where it is, we have to simplify it. So we multiply by the conjugate of that thing. If you're with me on that, that would turn the top into this. They're really just asking you, where is the hole? Okay? You all with me on this? Boom. That's what that is if you multiply by the conjugate. Top and bottom, it squares out the top. But again, all they're really asking you is what's the limit as we approach 2. There's a whole discontinuity. They want to know where it is so we can let k equal that thing. All right? Turns out that the top simplifies into, look, x minus 2. Hope you all see that? Yes. So this is really just x minus 2's cancel 1 over the square root of 2x plus 5 plus root x plus 7. At 2, now I can plug in 2 because I removed the hole. I canceled it out. When I put 2 into that, I get 1 over 3 plus 3. I think. Yes. So if I want that to be, so here's what that means. That this function right here at 2 looks like this. There's a hole, boom, the y value of that hole is 1/6. If I want it to be equal, or continuous, I need k to be a 6th. That's it. That's all I want you to do. Okay? When you see questions like that, that's just like a limit question in disguise. Great. 1/6. Boom. Okie dokie. You ready? Same thing. If f is continuous just means it's all connected. There's no holes or jumps or anything like that. We know that this thing right here, do you guys see this? Yeah. Reduces out to x minus 2 when you factor that. Right? The x plus 2's cancel. That means there's a hole at -2. But when I plug -2 into there, I get -4 when you remove the hole. So to make it continuous, I need this to equal -4. It's the same thing as number 8. They're asking you what's the limit, plug in the point to make it continuous. I hope that makes sense. I don't know. That's also a semi-important question like for the AP test. When I say that, I mean you might see that on the AP test. Okay? That's what I mean when I say that. All right. 10's not really a super fair question. I don't know if you guys know this. Do you know sine squared plus cosine squared is 1?
I had to look up like my notes from last year. Yeah, that was.
Thank goodness you had those. Do you guys know that sine squared then is 1 minus cosine squared? Yeah. Which means that is just 1 minus cosine, that's a theta, times 1 plus cosine. Which means this is just 2 times 1 minus cosine theta times 1 plus cosine theta. Look at that thing. And the 1 minus cosines cancel, really. Okay? You could have also graphed it. Later on, we'll do L'Hopital's rule with that, which you don't know what that is yet, but it makes it super easy. Either way, this becomes a 1, this becomes a 1, and we can just plug in 0. So you get 2, a 1 over 2 times 1 plus cosine of 0, which is 1. That's a 4th. Yeah, you guys know cosine of 0 is 1? We discussed that unit circle stuff. Okay. The trig stuff's a little tricky. I wouldn't worry too much about that right now. We'll look at those identities later on. You should, this is like, fairly common knowledge, right? Everybody remembers Pythagoras, the ancient Greek superhero. He's probably a real jerk, honestly, in real life, you imagine, right? Okay. Let's talk about these. I think back in Algebra 2 or something, your teachers teach you like Boba and Baba and Boingo or something. I don't know. You guys, anybody remember that? Yeah, I don't really know. Here's what's going on. You ready? Let's think about this realistically. This is how I would like you to approach questions like this. And we're gonna have another little lesson on these. But when you see n is going to infinity, it could be x, whatever variable, it doesn't matter. That means it's getting real big. Okay? It's getting bigger and bigger and bigger and bigger forever. 100 cajillion, kabillion, kabillion. Okay? So as that happens, as n gets bigger and bigger and bigger, this n cubed absolutely, positively dwarfs 5n. Like n cubed is going to be like 100 trillion billion, And 5n is going to be like, 100. Okay, not really that big, but you understand what I'm saying to you? It's going to be gigantic compared to 5n. So as n gets bigger and bigger and bigger, the only thing that really matters on top is this. And as n gets bigger and bigger and bigger, the only thing that matters on the bottom is this. So this thing eventually approximates this. Okay, that's what's going on. The biggest terms on top and bottom are what take over as n gets really big. And what does that equal? 3. And you're going to say, but there's junk back here. Oh my gosh, you're right. And it's never going to actually equal 3. That's fine, but it's going to get close to 3. Because as n gets bigger and bigger and bigger, the big stuff matters way more than the little stuff. All right? You can also remember this rule. I'm not a fan of just memorizing rules. But you can remember this. If they have the same degree, then as n goes to infinity, that's asking for the horizontal asymptote, by the way. It's just a fraction of their coefficients. Okay? So that's also why it's 3. So 12 is the same thing. As n goes to infinity, that's just going to be 4. You see that? They're both n squareds. Okie dokie. 13 is the same thing. They're both x cubes. That's just going to equal 1 4. All right? No work whatsoever. This is what that is. Great. Where does this limit not exist? This should have been an easy one for us. Okay? Oh, does it exist? Sorry. This one and this one. Right? Boom. 1 and 2. Okay. We're going to do 18, 19. Well, okay. Let's keep going. This one's a little bit of pain in the butt. You guys notice the difference of 2 cubes?
It's like 8 minus 8
It sure is.
Oh yeah.
Okay.
I remember that.
That's how that factors. You can look that up, okay? But you might say, I can't remember all this junk. I've got too much other stuff going on. Okay? But here's what we also know. Ready? This is a cubic equation. A is just some number. All right? When I plug A in for x, I get 0. That means you're going to love this. A is a 0 of this polynomial. Look at that. You see that synthetic division happening? A is a 0, because when you plug it in, you get 0. Bring down to 1, multiply, add, multiply, add, multiply, add. So this must turn into x minus a times 1x squared plus ax plus a squared, which is what it was. So you can either memorize the formula, or you can just do synthetic division. It's the same thing. But either way, the x minus a's cancel. So you have 1 over that, and you plug in a, you get 1 over a squared plus a squared plus a squared. That's 1 over 3a squared. It's like magic. 16. Yo, in the future, when I have you do this and you got to put your answers on Canvas, I don't know how many, I don't think I have many like this. If there's no multiple choice answers and you just have a number answer, you just put that number in. Okay? But anyway, as we go to infinity, this is just negative 5/11ths. You see how they're x squared over x squared there? Those are easy questions, I hope. Yo. This says y equal 2 is an asymptote for the graph. You know what that means? It means y equals 2. At the end of the graph, when x is really big, it looks like that. That's what it means. Okay? It does not mean, I know sometimes your teachers back in the day told you that an asymptote is a line that a graph cannot go through. That's incorrect. Okay? Let's unlearn that. Graphs can go through their asymptotes. Graphs can go through vertical asymptotes if they want, but then it won't be a function. We can talk about it later on. It doesn't matter. All right? But an asymptote is just a line that a function gets infinitely close to, really. Okay? So this thing gets real close to this. It could do this forever. It could hit that line as many times as I want to. All right? But what it means is this. As x gets bigger and bigger and bigger and bigger, we could even say as x goes to infinity, f of x goes to 2. And I know you've seen that notation before. You've done that back in Algebra 2 and pre-calculus. That's called end behavior. Okay? As x goes to infinity, f of x goes to 2. And that is exactly what this says. I think a very common answer to choose that's wrong is B. Because it says, hey, it's an asymptote, so f of x can't equal 2. And again, that is not correct. Okay, what is this game? What are we playing? What is that? Is it evens odds?
We're not playing a game, y'all.
Really?
Yeah.
It looked like a game when you're
It looked
doing
like it,
this.
but it wasn't.
Trying to run through my head why students could be doing this secretly. You know. Okay, anyway. Yo. Hello, Miss Kennedy. How are you? So you came here? That is amazing. Yo, as we approach 0, look at this. Sine goes to 0, it looks like that. X squared fills in that 0 and goes like that until it gets to 1. It stops at 1, 1. That's what that does. 2 minus x at 1 fills that in and does this until we get to 2, which will be 0. But 2 there into here is negative 1, so that does this. Oh, there's an open circle there. This fills it in, and that does that.
So 2 only.
Just 2. I plugged in the numbers. There you go. Wow, 2. Is f continuous at 3? We know how to do this. If you put 3 into here, you get 2. So ready? Check us out. The limit as we approach 3 from the left of f of x, is that 2? Yes. The limit as we approach 3 from the right of f of x, that would be this function, right? That's also 2. So these are equal to each other, right? What does this show right here? It doesn't show continuity. It shows that both sides go to the same place. So what do we know? Well, could be a hole, but the limit exists. You know what we can say, Gabe? I see you. The limit exists.
The limit exists, so that has to mean that it's continuous.
Well, we got to make sure there's a y value there. What about this makes it continuous? One extra piece. The equal sign. It says when x is 3, that plugs the hole in, and that actually equals f of 3. Yes. Ta-da! There we go.